Alright gang, let's try another one. This time we've got a little scenario. A boat is moving through the water at 32 miles per hour at a west 28-degree north direction. The current against the boat is moving at a 6 mile per hour flow in a south 12-degree west direction. Which way does the ship actually move? So we're going to draw a sketch of what's going on here. We start with an east-west line. We're going to start with the boat being our first vector. It's moving 32 miles per hour west 28 degrees north. What I notice is it's 32 and the current is 6. So it's a little more than 4 times the length, and so I just want to keep that in mind with my sketch. This one should be approximately 4 times longer than the other. Actually, more than 5 times longer. Math teacher. So west 28 degrees north. This is west. From there I'm going to go up 28 degrees-ish towards the north. I really just want to make my picture large enough that I can fill in information inside of the drawing. From there, I fill in what I've got because I'm going to need that later in my drawing. I'm going to make my second east-west line that I'm going to feed off of, and this time the current is 6 miles per hour in a south 12-degree west direction. South is this way. I'm going to go 12 degrees towards the west. And I'm only going to go approximately 1/5 of that, so I'll just make it go to about where I drew that line. This is where it ended. My resultant is from the start to the finish. So I've got a very slender triangle. I know a little bit about the angles in the picture. This is only 6. This is my resultant. I'm going to need to find this entire angle. This part I know is 12, but I've got to find the whole angle so that I can use law of cosines with the 6, the 32, and the cosine of that angle. So r squared is equal to 6 squared plus 32 squared minus 2 times 6 times 32 times the cosine of this. So what do I know? I know that this is 28, which means this would be 28. So how can I figure out what it is from this over to here? Well, this whole angle would be 90, so I would take 90 and subtract the 28. I get 62 for this, but I'm going to add on to it this little bit, which was 12. So I've got 74 is my angle. Now I go back with that information and find the length of the resultant. So I'm going to do the square root of 6 squared plus 32 squared minus 2 times 6 times 32 times the cosine of 74. And I get 30.89. So the resultant length is 30.89. The unit has to be the same unit as the other two vectors, which was miles per hour. Again, it is not always miles per hour, just happened to be in this problem. And now I'm going to need to figure out the angle of that resultant. Well, the angle is from the east-west line up to the resultant vector, so it is from this part up to there. What I know is it's less than this 28 degrees that took us up to the first vector. So I'm going to need to figure out what this little angle is in the triangle. I again labeled it with a question mark. So I'm going to take the angle that I have here of 74 and use law of sines. So the sine of 74 over the resultant, 30.89 is equal to the sine of our question mark over, which side is opposite of that? 6. So 6 times the sine of 74 divided by 30.89 gets our decimal, second sine, second answer of that decimal. That angle for question mark is 10.8 degrees. This time I'm not adding. I'm going to subtract it from the whole. So I'm going to take 28 minus 10.8. Save myself time. I'm just going to subtract 28 and know that my answer should actually be the positive result of that, 17.2 degrees. That's my angle. Now I've just got to determine its direction. So the angle here is 17.2 degrees. Its direction is west, and then it went up towards the north. So the resultant was 30.89 miles per hour at a west 17.2 degree north direction. That's the result, that the boat actually moved because the current was forcing it in a little bit different direction.